Hello, Buddhists from around the world. My name is Kais and I am 13 years old and I live in Boston, Massachusetts. Welcome to our Oboot Zoom session where me and my co-host, Anya, who is 14 years old and lives in Cambridge, Massachusetts, will be interviewing our guest changemaker, Professor Deborah Hughes Hallett, who is currently based in the United States in, I think, Boston, Cambridge?
Well, at the moment, I'm in Tucson, Arizona. So I'm in the western part of the country, in the desert, right at the far southwest.
All right, so in Arizona in the United States.
Yes, it's in the United States. And other times of the year, I'm in Boston too.
All right. Professor Deborah is an adjunct professor of public policies at Harvard University and professor of mathematics at the University of Arizona. She graduated from Cambridge University in England and has taught at Middle East Technical University in Ankara, Turkey, and Universiti Brunei Darussalam. Her work has been recognized by prizes from Harvard University, the University of Arizona, the Association for Women in Mathematics, and the Mathematical Association of America. Professor Deborah's work links to several sustainable development goals, especially the goal number 4, quality education. Anya and I will ask questions to Professor Deborah about her background, her journey, her work, her skills, and her impact. We hope that you will enjoy the session, and I will now start with our first question. Can you please tell us a little bit about your job and you?
Sure. I have 2 different positions, and they're somewhat different, but at the core, they're similar. I teach both at Harvard University, at the School of Public Policy, where I teach, or the School of Government, where I teach students of public policy and public administration, how to use mathematics and data and so on to make good and useful public decisions. At the University of Arizona, I teach mostly undergraduates. At the moment, the group I'm teaching are interested in the biological and life sciences. They're going into medicine, nursing, public health, but they also need to learn how to use mathematics to help their work. So in both cases, I'm teaching mathematics and statistics, but I'm teaching them to 2 different groups of people.
What subjects interested you during school and why?
So during school, this was a long time ago, and it was in UK, it was in England. I was always interested actually in the sciences, physics, chemistry. I found eventually that mathematics was what made both of them work. And then I realized that what I was interested in really was the mathematics. But I did a lot of other things, as I'm sure you are too. I did, all kinds of history and English, and I was a potter for a while, making pots. But the thing I like best is mathematics.
Why did you choose to teach public policy, and what does it mean, and how does it link to mathematics?
I think that mathematics can play a useful role in helping people in many fields, but this includes public policy, make better decisions or make better use of their knowledge. For example, if you want to combat climate change, one of the things you have to figure out is where a change in regulations can have the biggest effect. You want to work on things that can have a big effect. Similarly, if you're a medical doctor, for example, over the last few years with COVID, it's important to figure out how the vaccines that were being developed work and how and if and who they will help. So these are actually both public policy decisions about how people should run the world. And I believe that having public servants who can use their mathematical thinking well is good for the world. Many of them, maybe not you, but many people, grew up in a time when math was taught in such a way that it looked like it had nothing to do with anything else in the world. It was a separate algebraic kind of thing. And the world has changed. And I think that public policy people and other professionals need to be able to use data and computing and the kind of modern mathematics, which might be very different from the mathematics they had in school many years ago.
As you said that the study of mathematics benefits the society in terms of addressing racial inequality and climate change, could you please explain more on that? I didn't really understand that.
So to address many of the world's problems, whether it's climate change or inequality, racial or gender, or any other sort, to address them, you need to make some policy changes, to make a new law, for example, to make a new decision about how cars do or don't emit emissions. Car emissions are a big part of climate problems. For the point of view of racial injustices or racial justice, you might need to think about different educational systems, different legal systems, different sentencing systems for prisons and drugs and so on. So those things are all policy changes. But if you are a government official, or how do you decide which policy to choose? How do you know which policy actually might have a big effect? How do you know if you make a new policy that it actually worked well the way you want it? And those decisions about how do I know what to pick and how do I know whether it did a good job or not they're not only mathematical, but mathematics and statistics are crucial in helping us do that. For example, there is a lot of evidence, numbers and so on, that greenhouse gas emissions, that's burning gasoline in the car as you drive to the supermarket or you drive to school, is a problem. That is fairly well established. There is some evidence, this is not clear yet, but is coming, that there are other sources of climate problems which are potentially more impactful and more dangerous actually than the carbon dioxide you already know about. For example, methane, or in the US it's called methane, which comes both from cows and also from, there are sources that the Japanese, I think, have discovered, somebody has discovered, that there's a lot frozen in the bottom of the sea, which as global warming happens, means that that's starting to get emitted. That potentially is more powerful than cars. What does that mean? Don't get scared. It means that we maybe need to think hard and quickly about doing things about methane, because otherwise that may overwhelm our effects of looking at carbon dioxide. So it helps you choose amongst the policies, and the mathematics does, and it helps you evaluate whether the policy was useful or not useful.
Okay. What would you say to somebody who thinks like math isn't like relevant in the world?
There are plenty of people who think that. Plenty. So it depends who I'm talking to. But many students and many adults feel that mathematics isn't useful because they have never seen it be useful. Okay. This is actually a lot of what I try and work on. So I think the things that would be helpful is to ask the person what he or she or what they are interested in. If they're interested in climate change, I would give an answer in terms of climate change. If they're interested in some kind of justice, which was quite possible, I would give an answer in terms of that. If they're interested in entrepreneurship, starting a business, economic issues, I would give an answer in that. Because I think that people listen to answers more closely if they're related to what they actually care about. And I think there's a good reason. I mean, I don't know how it is for both of you, but I know from my education, it was not very clear what mathematics was useful for. I enjoyed it. I was probably unusual in this respect, so I just enjoyed it for itself. But many people think that it's not useful. You're perfectly right.
So what, like, as you said that maths, like, you just liked it for itself, but like, do you think like you were attracted to maths for like something else, like in the future? Like how you said some people are attracted, some people like for example, justice, you said. So like, what if you're interested in justice and then you would explain math in that situation? So like, what attracted you to math? Like,
looking at my own history, which is not most people's history, I think I was interested in it just for itself. I loved the physics. I loved figuring things out, but I liked doing it in theory. I didn't like doing it, and I wasn't, some people build things. I was not a building things. I like to figure out the mathematics of it. I don't think that's everybody. It was me. And so at the time, that was why I got interested. When I started teaching, I was and from my own friends in school, I knew that most people weren't interested in math that way. It was clear that I was, that was something that was me, but it wasn't everybody. And so if you want to teach more generally, you need to learn a lot about the applications, I think. I personally didn't start off, I was never taught the applications. I was taught abstract, pure math that had nothing to do with anything. But I loved figuring out what it was useful for. So I figured out what it was useful for. And for teaching, that's very important. If I only lived my own life and didn't ever teach, I've taught a lot, I would probably not worry as much. Well, actually, I probably would. I was very interested in how it was applied. And I was always actually very interested, this is not quite your question, but it's a little bit related. Even when I was quite young, in school and college and so on, I was interested in why people, my friends, didn't find math doable, because they often didn't. And I was pretty sure that if we were able to explain it calmly and in their own words, not in formal words, I could get them to understand stuff more. And that seemed to me a form of injustice. I probably, when I was 16, I wouldn't have said it to you in those words, but I was already aware of that idea.
Okay. What do you like teaching more, public policies or math, and why?
Okay, so let me not answer your question directly. I hope you will allow me to do this. mean, why do I have two jobs? Because I love both of them for different reasons. Okay. Teaching math requires two things in my head. One is you have to like the math. Otherwise, why spend your life doing it? But you also have to like the people that you teach, because fundamentally you're teaching math, but to people. And I like both groups of people. I love teaching at the Kennedy School because your parents and other people are wonderful, wonderful people and very interesting. And I wouldn't miss them for the world because I learn a lot from them. At Arizona, I teach people who are actually closer to your age. They're a little bit older, but not much. They're freshmen and sophomores at the university. They're also wonderful people. They're at a different stage of their lives, but I wouldn't miss them for anything. Okay, they're super. And some of them will go on and do all kinds of things. Like, for example, somebody that I had 2 years ago, this is at Arizona, is an undergraduate. She's very interested in biological research. And she just got a job in a biology lab. And one of the things they love about her is that she is able to program in Python. They've never had an undergraduate who could program in Python before. And she learned that a lot from the course that I taught her. Okay. And it's just wonderful to see her beginning to realize that she could be a professional biologist, because she's in a lab, she's doing something, she's contributing something that nobody else in the lab can do. And it makes her very happy, and that makes me happy. So I wouldn't miss either audience. And the mathematics is common, but the audiences are different. Forgive me for not answering your question, guys.
It's all right.
Since you have worked with different teachers from different countries and cultures, how has your experience been with them, and how is maths perceived in different countries?
Well, that's a great question. Yes, you're so right. So the US and a lot of the West, actually, but not only the West, is inclined to believe, and I strongly object, that mathematics, either you're good at math or you're not good at math, and there's no point in trying because it's all biological. Okay, that's a little overstatement, but there's a lot of sense in the West that, if you're not good at math, that's just nothing you can do anything about. How often have you ever heard somebody in the West say, "Oh, I'm not good at reading"? What? Okay. People are less willing to give up on other subjects than math. That's not only the West, but it is very strong in the West. And it's complicated by things like women in the West tend to think that they're just bound to be worse at it, and that is not good. There's considerable research evidence that people in Asia, I don't know how you found this, particularly Japan, China, Korea, I don't know about India, feel that doing well in math is a matter of working at it, okay, which is true. Okay, it helps. So that's one kind of difference, whether they think people are just naturally good, and if you're not, you should give up. I strongly disagree. The other place that there is a big difference is how much you do or don't try and get students to understand what they're doing, okay, as opposed to just remember what they're doing. So there's been a lot of change over the last, tens of years. When I grew up, I was in England, but I had an education that I thought I was supposed to memorize everything to do. And actually very bad at memorizing things, and I'm quite lazy. So I hated that part. So I used to make up little stories for myself about why this worked. Okay. Basically, I was figuring out why it worked. I wasn't always correct, but I had something. So in my head, I had a picture of why this worked. And that way I didn't have to remember anything because the picture made sense. But I always thought that was evil. So I never told the teacher. Now, I actually think that what I was doing was very useful. And there are definitely differences that some countries push memorization much, much more. And I think that's a problem. Okay. And the idea that you should make sense of what you're doing is not universal across the world. So I think the two things that I have found different is the amount of attention to memorization, and also the amount of speed at which people, the amount of attention to thinking that there's nothing you can do about it. If you're not good at math, you're not good, you should give up.
Okay. So what would you say is the most enjoyable part of teaching?
Seeing somebody suddenly realize what they can do with what they've learned. I mean, it's watching somebody grow mathematical wings and take off, suddenly see that they could do something they never thought they could do. Okay, so another example, my student who learned Python is in that category. Somebody else, this is at the Kennedy School, who came in being terrified of math. She said I gave her a headache every time I talked to her. It was not a good start. But she actually got quite good at it, and it wasn't painless at all, but it worked. And by the end of it, she went off after finishing the Kennedy School, and she got a job which was partly based on her ability to do mathematical things, make graphs, make charts, make all kinds of stuff that gave evidence for women's progress, actually. And having her realize that, seeing her headaches melt and go away, and be replaced by the ability to do something useful with it was great. So that's definitely for me, that's why I do it.
I need help in maths. Did you need any help in studying when you were in school?
I used to ask, and I still ask, lots and lots and lots of questions. And that's actually very helpful. I used to make, I think it was a huge nuisance, but it was very useful. I used to make lists of questions. I had, this was before the computer days. So I had a back page of a notebook. And on the notebook, I would write questions. As I went through studying things, I would write questions. So I would end up with this enormous list of questions. And then I would take my list of questions to office hours, and I would ask them. What happened to me a lot, and this might be, you may find this happening to you, is when I got there and started asking my questions, as I verbalized the questions, I would sometimes understand what the answer was. So saying it out loud made me figure out, oh, that's what's going on. And then I would get to the end of the question, and then I would say, oh, never mind, I've figured it out. And so we'd go on to the next question. So that taught me that verbalizing things is very useful. The other thing, so that was asking lots of questions was super helpful. As a result, I once had a student who came in to see me, so now the other way around, and she had a list of questions, and it was 46 questions long. And I thought, this is me, but later, I'm going to answer every one of them. And we went through 46 questions, and I'm very glad I did. Another thing that was very important to me was to have a visual picture of what I was doing. I think in pictures. Not everybody does. Some people think in symbols, some people think in words, but I'm a picture person. And certainly at the university level, I was learning what was called, it's linear algebra. It's something that you probably haven't had yet, but you might do one day. And it has vectors and matrices and so on. And I was very perturbed, I'm still perturbed, by not having good pictures of what some of the operations meant. So for me, I spent some time going around in circles at university, talking to everybody I could find to bother, and say, how do you visualize this? And most of them, it turned out to be a rather hard question, so I never got a thoroughly satisfactory answer, but I got a sort of an answer. So being able to visualize and being able to answer questions were super important to me.
Okay, so in your Harvard bio, it mentions that you are interested in promoting international cooperation between mathematicians.
Yes, that's
what does
correct.
That look like?
Sorry?
What does that
like
look
what? You'll say. So let me give you a specific example. There are many countries at the moment that don't altogether get along. You know many of them. Mathematicians, because they are quite often very devoted to their subject, can be quite useful in this because mathematicians from opposite sides of a political divide often share something, which is devotion to mathematics, which can help. For example, I ran about 20 years ago a series of conferences in the first two were in Greece and the third one was in Turkey, and this was for mathematicians from all over the world, but a lot of them were from the Mediterranean area, but not all. And at the third conference, at the second conference, sorry, which was in Greece, was actually in Cyprus. It wasn't in Cyprus. Sorry, it was on a Greek island. It was on a different island. I was on Crete. The question came up. There were two mathematicians from Cyprus, one from South Cyprus, which is the Greek side, and one from North Cyprus, which is the Turkish side, who had been talking about what would happen if and when the two halves got united. Okay. Now, they haven't been united, but at the time it actually looked quite possible as though they might. There was a UN resolution which failed to put them back together, but whatever. So these two mathematicians were interested in how the school curriculum in high school would look if the two halves of the island were united. Because at the moment, one half was Greek and one half was Turkish. And they did different things because there were two different countries, and the two countries were not easily on speaking terms. There's been a lot of bad history. And without going into anybody about whose bad history was whose, what they did was to figure out how, if the two halves got united, how they would progress to make a single curriculum and teaching method for the whole island. It was quite tricky because there were very few places in the world that they could easily meet, because they came from countries that were basically not in good terms. But that's the kind of cooperation which can be possible, because both of them were quite committed to doing something that was mathematically sensible and workable and productive for their population. And the mathematics was strong enough to bring them together. Now, the islands didn't get united, so it never played out, but that's the kind of thing I'm talking about.
Involved in deciding the undergraduate maths curriculum, what factors do you take into account while deciding it?
Well, okay. One of the things that's very different in the US and in some other countries is in the US, most students, if you go to college in the US, this will be for you, go to college without deciding their major. So you can come in as a freshman at Harvard or at most schools and not say, oh, I'm going to be a physicist, I'm going to be a biologist. You decide that later. This is different than in many countries. For example, I taught in Turkey for a while, and it was different. In Turkey, you came in as a biologist or as a mathematician. So why does that make a difference? Many math courses are taught to American students as freshmen, and they don't know where they're going, or they haven't decided where they're going. So the math that's taught has to be good for everybody. That's a very different requirement than if you do it. I don't know how it works in India, but I think you might go in India as an engineer or as a whatever you go in as. If I know that you're going to be an engineer, I'll do this, okay? Because I'll know what you have to do later. If you go in the US, I've got to give you a much more broad and flexible background because I don't know what you're going to do later. And so looking at the mathematics and also the goals of the students varies quite a lot from country to country. And in the US, particularly, flexibility is extremely important. It isn't as important necessarily in other countries. So there's a cultural component as well as mathematical component. And by and large, I also think, this is particularly in the US, that mathematics needs to be made accessible. You don't want to flunk out half the population in the first year. What a waste.
Okay, so what would you say is the difference between online teaching and in-person teaching?
This is a super good question, and I hope we'll know better in a few years. I thought online teaching was going to be really hard initially. I'd done some, but not a whole lot. It was less hard, and partly what was helped, so this is a good thing about online, is Zoom chat or something like it. When I'm teaching in a big classroom at the Kennedy School, like last semester, I'll have 90 people, and some people ask questions, but the back of the room doesn't say much, or some people don't say much. On chat, I found that some people ask questions by turning on their mic, like your guys are doing, but also people who were kind of shyer or not so confident put questions in chat. They didn't want to ask them out loud because they didn't feel like confident enough, but they put questions in chat, and my teaching assistants would then answer them in chat. And they would say, oh, does she mean this or this? And the TF would say, this. Okay. And so I heard from a lot more of the class during online, which was surprising, and it was very useful. And it's made me think about how to do that now in person.
Do you have a favorite genre of music?
No. That's the quick answer. Most mathematicians are quite musical. I happen to be a complete exception, and I was always interested in the arts, in pottery and painting and so on.
Thank you, Professor Deborah. and Anya for the great discussion and for all the things that we learned today. Thank you, Obootus, for listening to this interview. Make sure to follow us on Instagram and Twitter and to subscribe to our YouTube channel so you can hear about upcoming sessions with other changemakers. And please also tell your friends about Oboot and share social media links with them. And last but not least, go to oboot.co to learn about opportunities to draw down carbon and get badges.